Hello everyone, today I'm going to go over again the worksheet we were working on. We already answered question number 1, but I'm going to review that again. So let me get a pencil and I think the red color will work. So the first thing was, the question was asking to find the molecular formula and the structure of the compound. And the first thing will be finding the empirical mass of this compound, which is CH2O. And if we do the calculation for this one, will be 12 carbon plus 2 hydrogen plus 16, and that will be 30. That will be the molar mass of the empirical formula. So if you notice here, this is the maximum number we get on the spectrum, which is 60. So when we divide 60 over 30, the answer will be 2. So the real molecular formula will be 2 times the empirical formula, which is this one. So we need to multiply this by 2, and that will give me C2H4 and O2. And then based on that, we can deduce the structure of the compound. And one of the students came with the following formula, and that will be one. So we had 2 carbon and 2 oxygen. So it seems like it will be ethanoic acid, or also called acetic acid. So we will have 3 carbon attached here. Sorry, 3 hydrogen attached to the carbon, and that will make the 4 hydrogen for the first one. So this is a hydrogen also. So we have 1, 2, 3, and 4 hydrogen. So this is the same. We go here, and then we have 2 carbon, 1 and 2, and 2 oxygen. So that will be the answer for the first one. Next thing to do is I'm going to scroll down to the second question that will be asking you the mass spectrum of 2 compounds are shown below. One is a propanone and the other one is a propanol, and this is a ketone and this is a aldehyde, and we have to identify both of them. So let's go over the formula of both of them first, and then we will identify which one is one. Let me grab the pencil again. So the first one, the propanone, will be, this is the formula for that one. So we have a CH3, a carbon with double bond of oxygen, and then the other methyl group here. And then we do have the aldehyde, which is this CH3, another carbon here, and we need to add the double bond with the oxygen. So we have already 3 bonds to the carbon, and the other one will be the hydrogen. So let's recount again. 4 hydrogen, 4 hydrogen. We have here. Sorry, I missed one of the. CH2 groups. So let me erase this one and write down again CH2. And I can do this because that's the way we can write organic compounds. So we actually have 3 carbon, 1, 2, 3. This is a CH2. For those of you who cannot see, this is a number 2. Let me rewrite that one again. Number 2. And that will be CH3, CH2, and that will be the aldehyde formula. So the next thing will be identify the compound, the spectrum for each compound, and my answer will be the aldehyde will be this one. Why? Even both have the same molecular mass or molar mass, when you take away one hydrogen, it goes from 58 mass to 57 by losing one hydrogen, while the ketone will lose the whole methyl group. It goes from 58 for 43. How do I know that? By actually, this is a carbon 12 plus 3 hydrogen will make a 15 gram. So let's subtract 58 minus 13, and that will give me what? 5 and 45. Do we have any 45 somewhere? No. So we need probably to check again by losing 16. Okay. We need to find the combination that will give us the 43 here after you had the molar mass of 60. So we had 58, and 58 minus 43, let me do the other way around, is losing 15. Yes, sorry, I was right. This is the 15 that is being loose here of the methyl group from 58 to 43. I don't know how I come with the 13 here, which is actually 15. So this is the one. So anyways, the answer is this one will be the ketone, and this one will be the aldehyde. One more time, this one will be the ketone here. Or yeah, sorry, let me go back again. Let me write this one. Let me grab this one will be the ketone, and this one will be the aldehyde. And they say the similarity will be they have the double bond carbon oxygen. That will be the similarity of both. And the difference will be this is a primary carbon joined to another carbon, and while this is a secondary carbon joined to two methyl group who has each one has a carbon. That will be the difference between the two compounds. So next thing to do is let's go to number 3. They gave us a compound and they gave us the composition, the 51, 52, 1 carbon, 52.5, hydrogen 13.2, and they gave us the atomic mass. I just did a calculation following the rule. I'm assuming I have 52.1 gram of carbon, so I will divide that by 12, and then I will have 13 gram of hydrogen, 13.2 of hydrogen. I will divide that by 1. That will be the gram over gram mole, so that will give me the number of mole for each one. And the oxygen will be 34.7 divided 16. And that will also be the formula, the number of mole of oxygen on this one. So going to the question again, let me scroll down and see the empirical formula of the compound. You need to do this calculation first, and then you have to determine the molecular formula and draw the all possible structure of compound A and explain the fragment of 15. That's an easy one. Let me answer this one. This is, I'm pretty sure this is a methyl group. There is a methyl group here because carbon 12 plus 3 hydrogen will give me the 15. So that will be methyl group here. That will be the explanation of this peak here. And the compound, I just did all the calculation, will be an ester. That will be this formula. And then you don't have to answer how many structure the compound have because that will be a topic for organic chemistry. But just to give you, there will be some isomer of that compound, but you can do the calculation and find out the compound for this one. So this is the answer for that worksheet. Hopefully my explanation will help you to understand better how to answer that. Thank you for watching.